So weather versus climate, what is the difference between those two terms? Weather is short-term atmospheric conditions. So that's what occurs over hours or days. So if I walk outside and I take the temperature or the air pressure, humidity, precipitation, cloud cover, wind speed and wind direction, those are weather conditions. It's day-to-day changes, whereas climate is a pattern of weather over a longer period of time. Usually when we look at climate, we look at two of these factors. We're looking at temperature and pressure. We start with a 30-year average, but it can also be from decades to thousands of years. All right, so a quote from Mark Twain, climate is what we expect, weather is what we get. So climate are the averages over a long period of time and help us with making seasonal predictions, but weather are those day-to-day changes. All right, the next thing we're going to look at is how Earth's geography affects climate. So looking at this diagram, the way that we divide climates is based on latitude. So we have tropical right at the equator, again, because that's where we have the highest amount of insolation. Then on either side of that, we have our subtropical, temperate, which we are located here in the southeast United States. Then we have subpolar and polar climates. Now, various biomes fit into those because it's not only based on temperature, but also precipitation and the amount of plant life found there. All right, so what we're going to look at and what determines climate, in addition to the latitude or distance from the equator, is global air circulation. So this is like the 3D models we created in your notes and that we looked at in a previous module. We'll talk about ocean currents, both surface currents and deep currents. And then, as we've already said before, with the tilt of the Earth and how the angle of sunlight affects the insolation. All right, so starting with our ocean currents, these are surface currents. They are indicated by color, red or warm currents. They originate at the equator and move away. And in blue, we have our cold water currents that originate in the Arctic and Antarctic and move back towards the equator. So notice in the southern hemisphere, these gyres, as we call them, rotate counterclockwise, and in the northern hemisphere, they rotate clockwise. And that's because of the Coriolis effect, the fact that the Earth is rotating at all times. So here on the East Coast, we're affected by the Gulf Stream, which carries warm water from the equator up the East Coast, all the way up into this North Atlantic current into Great Britain, Norway, Sweden, that area of Europe. Whereas on the West Coast, we have this colder California current that's coming down from Alaska, which is why if you stick your toe in the Atlantic Ocean at this latitude and the Pacific Ocean at this latitude, the Pacific Ocean's going to feel pretty icy compared to our warm Atlantic. All right, so with this California current that starts up here in the Bering Sea, it actually gives California more of a Mediterranean climate. It's very dry, which is why seasonally there are wildfires. When we talked about biomes, we talked about that chaparral or Mediterranean biome, again, because of those colder currents. All right, in addition to these surface currents, which are driven, let me go backwards, which are driven by our winds, because if we look at our wind patterns, they tend to follow similar patterns. We also have deep currents that create a conveyor belt, and these deep currents are based off of density differences. So we have this warm current along the surface that moves towards the poles. At the poles, when water freezes, the salt's left behind, so the water is more dense, not only because of the colder temperature, but because salinity increases. So that water sinks to the ocean floor where it moves back towards the equator, and I get this conveyor belt. So what this conveyor belt does, it brings warmer water to the poles and carries colder water back to the equator, so that regulates climates. Now, if this conveyor belt shuts down and I'm no longer carrying warm water to the poles, that's what puts us into an ice age. The poles will start freezing over, The equator temperatures actually get warmer because there's no more cold water coming back. And then once that happens, density difference starts changing and the conveyor belt starts up again, and that leads us into a period of warming. So that's what we're in right now, a period of warming. Our ice is melting. So eventually that's going to shut down this conveyor belt, which could lead into another ice age. All right, so other effects on weather and climate. We'll look at some geologic and geographic factors. So how mountain ranges can affect climate and how proximity to larger bodies of water. All right, so starting with mountains, if you have a mountain range that's close to a coast, we get what is called the rain shadow effect. You've got moisture coming in off the water. Where it hits the mountain range, it's got nowhere to go but up. Where it cools, condenses to form clouds, and leads to precipitation. Well, now that mountain range is blocking that cloud cover from moving, so we get a rain shadow or drier conditions on the backside of the mountain range. We call that the windward side and the leeward side. All right, proximity to water, we get what are called land breezes and sea breezes. So during the daytime, the land heats up much faster than the water. Water has a high specific heat, high heat capacity, so it takes a long time and a lot of energy for it to change temperature. So the water is actually cooler during the day. The land is hot, so that warm air rises and the cooler air from the sea comes in to take its place. So we get this convection current going. Well, at nighttime, the land cools down pretty quickly, and now the sea temperature, which hasn't really changed from the daytime, is warmer than the land. So that convection current changes direction. So now the warmer air off the ocean rises, cooler air over the land sinks and goes back to take its place. So at nighttime we get what is called a land breeze because the wind is coming from the land moving towards the water. All right, your proximity to the coast or a large body of water can affect your climate because water takes a long time to change temperature. It moderates climate. So the air that's above the water is going to be influenced by the temperature of the water. It takes a lot of energy to change the temperature of the water, so the air is not going to change that much. So if you live near a large body of water, you're probably going to have cooler summers and warmer winters than, say, a place further inland. You'll also have less of a range of temperature between day and night. Whereas if you're farther inland, in a very dry area, you'll have higher extremes of day temperature, night temperature, and also higher extremes between winter and summer. So for example, if I look at these two cities, City A, which is this line right here, you can see from January to June and July, there's quite a range of temperature. Whereas City B, that's closer to a large body of water, the temperature rises slightly in the summer, but not quite, doesn't get quite as cold in the winter. So again, looking at another example, if I compare Virginia Beach to Wichita, Kansas, here in January the low is 31, July is 89, whereas in Kansas I have a low of 20 and a high of 92. So a much greater range between seasons there. All right, the last thing that I want to talk about is upwelling. This is another phenomenon that happens near coasts, but also can happen in the middle of the ocean as well. But what upwelling is when that deeper, colder, nutrient-rich water moves up to the surface. This is important because it causes mixing of the water, so all of that material that is sunk and decomposed that's caused this nutrient-rich water can be brought to the surface. And that usually happens when surface winds push that warm water away from the coast so that that cooler water can rise. In red on this map are areas where upwelling occurs. It's really good for fishing industry if you have that cool nutrient-rich water come to the surface. And again, you can see it's mostly the thicker areas are on the west coasts of these continents. All right, upwelling can also occur far from shore. So for example, where the trade winds meet at the equator and curve, remember they're clockwise in the northern hemisphere, counterclockwise in the southern hemisphere, where it pushes that warm surface water away, the cool water from below can upwell. So we call that equatorial upwelling. And again, along those steep western coasts of some continents, the surface winds blow that warm surface water away from the land, which allows that cooler, nutrient-rich water to replace the surface water. So that may be because of a wind blowing parallel to the coast, it might be blowing off the coast, but either way, that warm surface area gets pushed away so that colder water from below can rise to the surface. And you can see that here in this animation as well. Okay, and that is it for our effects on climate. So I'll wrap that up.